Welcome to Natural Habitat Adventures Daily Dose of Nature. Today's topic, stranded salmon and hungry bears, impacts of the climate crisis. Presented by NatHab Expedition Leader Kristina Disney. I'm your host, Rob Mess. Thank you all so much for being here with us today. Take it away, Kristina.
Thank you so much, Rob. And hello, everyone. Thank you for joining and taking some time out of your day. I realized I made a bit of an oops. I was a bit behind on my title update, but we're all talking about the same things. The goal of today's conversation is to talk about stranded salmon. If maybe you're from the Pacific Northwest or from along the Pacific coast, if you're not, we're going to tie in a lot of information that maybe you didn't realize was going on out in the world. So for folks who've joined before, you might already know this. I was a prairies girl originally. I grew up in southern Saskatchewan, kind of where that gold star is, pretty close. And I've been living out in the Pacific Northwest since 2021. I made the move. I now live on Vancouver Island. And like many folks who call the Pacific Northwest home, salmon have become, I would almost say, if not a weekly, an everyday conversation, because you start to realize that these keystone species are intrinsically tied to our whole ecosystem on all these different levels. And after I made that move for myself, big, really hot topic, maybe pun intended. So if you notice, I said I moved here in 2021, which for this part of the world was the year that we had an historic heat dome. And it really, I was from a place that was hot and dry. So actually, when I moved here, I was kind of comfortable, to be honest. And all the locals that I'd moved in with, my roommates and people in the city, were dying. They didn't have ACs, everything, they just weren't ready for it. But the reality also is not just the people, right? The ecosystem isn't ready for it. These are, because of the ocean, because of the coastal mountain ranges, they're very moderated. And so in sort of a fun comparison, this was a slug I found on my field notebook last week or the week before. And if we look at our fun little slug friend here, it's kind of a perfect example as to why our coastal rainforest doesn't handle heat very well. The slug is kind of an embodiment of that, right? They're used to being in this lush, moist environment, and they're used to sort of giving and exchanging moisture freely. It's never been in a deficit. But that story is changing quite a bit. And I want to bring everyone's attention to a local story that's had a big impact, certainly on my life and on my work. So when I'm not guiding for NatHab, I still work as a PhD student here on the coast, and I work on one watershed, and this is very close by to where I work. And so last year in 2023, there were more than 80,000 salmon fry, or probably a mix of resident trout as well, that died in the river. And so the community has actually come together. There's a bunch of management actions that are happening, but the community itself is sort of coming together in different avenues to mourn that loss. Because salmon really are tied to multiple different cultures here, to people's livelihoods, whether you're an ocean fisher, whether you're even a forester, right? It's those nutrients that those salmon are bringing back from our oceans that are keeping our forests strong and healthy, or that's what we're hoping for. And so it was a huge loss. And so trying to quantify that and understand it, it's becoming more and more important, because it was because of essentially drought stress was the reason why these young salmon didn't survive. And so this is a kind of a cool graph. This is specific to 2021, but I just want to show it to exemplify what we're talking about here. So what we're likely, predicted to see in our future as our climate crisis continues to sort of build, is that we're getting these really hot, intense periods. And they're likely to be more and more prevalent, right? They're likely to happen more and more. So you can see the darkest of reds we were getting in along the Pacific Northwest and kind of down into the States as well, and a bit into the interior. So for some folks, you might be wondering, well, why does the temperature matter, right? What is it that happens to especially young fish, right? Salmon fry, that they can't tolerate it? And it comes down to a few different things. One of them, from our fun whale, right? If you think about our own bodies, right, when it gets too hot for us, we have a hard time functioning. Thinking about we like to give kids freezies in the summertime. It's not just because, they enjoy the sugar rush, but you're thinking about those younger, smaller bodies. They have a harder time getting adapting to the heat. You're more likely to get heat stroke when you're older, younger, vice versa. Another one you and I take for granted all the time is we can just breathe in our oxygen. We don't have to sort of mediate that through our environment. But for the fish, right, increased heat starts to take away some of their oxygen. And also, I mean, in some ways, kind of the most obvious one is that it shrinks the size of their home, right? So what ends up happening is we end up getting fish stranded. They might have moved upstream, they might have gone up a ditch or a slough when there was really high flows in the springtime. But then as the summer declines, they tend to they hang out or they go to the pools where there's the deepest, coolest sources. But that doesn't mean that that's going to keep them connected to their parent river, to their parent stream. And so when they get stranded, that's what can lead to a lot of insecurity in the population, right? That's when they're at their most vulnerable. And so I kind of love this. I want to flip that notion of big fish in a small pond, that saying, right? Because we always think about, the fish growing bigger than the pond when we say, oh, you're being a big fish in a small pond. And he has the joke at the bottom. Remind me again what's so great about this? But for a lot of fish in real life, in their ecosystems, it's not that they outgrow their environment. It's that in times of stress in these intermittent streams, their home actually becomes too small for them, and they don't have anywhere else to go, right? They can't pick up and just kind of well, there actually are a couple fish out in the world, but that's a different story. That would be a different conversation. They can't pick up and move, right? And so this brings up a really big question as far as ecosystem management and stewardship, and what is our role as humans in these ecosystems. So I want to introduce you to a concept that's called assisted migration. I think this picture is so great because I think it's such a cheeky little cartoon of all the fish, or all the trees with their backpacks, because we don't often think about it. But even trees migrate, right? They move with temperature ranges. But what assisted migration essentially is, besides this great cartoon, is it the idea of translocating an organism that is either from its fragmented or non-native habitat, or not non-native. It can be non-native. It can get more specific. But I just want to say that it's very controversial, and it's been done intentionally and unintentionally in the past, and there are severe repercussions either way. And that's why it's so controversial. It kind of comes down to the question of what right do we have to move things, or what right do we not have? And so that, again, comes down to different governances where you're at. Even your own morals are going to come into play here. But smaller scale, we often think about it as relocating individuals. And this is really common. Problem bears are a perfect example, right? You have a bear that gets habituated to a certain area. And what they do is they will, most likely tranquilize it, pick it up, and move it into a different valley or a different system. So it's still in the same ecosystem. And so when we think about this again from a moral perspective, there are some forms of assisted migration that we are very comfortable with, that we use all the time without even thinking. You might not even think about it, but when you pick up that spider, if you're one of those people who doesn't squish it, you grab it in your house and you let it go, that's a form of, albeit small, assisted migration. And so, so it's used in a lot of conservation tactics or decisions to not use it, right? There's times and places where people have decided they don't think it's their place to intervene. But one of the probably a very small, really ubiquitous example is what we're going to focus on today, which is called fish salvage. So that's the idea of recovering some of these fish, and that can happen on a lot of different levels. And so some of that happens with climate change. It's becoming a hotter and hotter topic with our hotter and hotter weather, is whether or not we should be doing captive rearing, right? Taking these fish that their ecosystem becomes too fragile for periods of the year, rearing them in our somewhat, I'm going to say, safer environment, and then re-releasing them again. But this comes with a bunch of issues in and of itself. One thing that's really big is the idea of genetic diversity in a population, and how the natural selection order gets knocked out of balance, and so then you have different genes passed on. Is that a good or bad thing, right? It's actually not a black and white answer or question, really. And so this form has been happening a lot, captive rearing to save species from extinction. Again, this is something that we are all extremely familiar with, even if we don't think about it that way. And what I'm talking about is zoos. Zoos are an incredible example of captive rearing that we societally accept to varying degrees. Actually, everyone has different opinions on zoos. I'm not a big zoo fan, but I do think in some ways they serve a purpose, but it depends on where you're at and how your zoo conditions are. But I'm getting slightly distracted. So what a lot of scientists out in the community, we think about this notion of sort of that zoo mentality of, oh, we're going to take the species out of where it's harmful and keep that species alive. And so it's called the Ark strategy, is kind of how we've come to refer it, kind of like Noah's Ark, right? They couldn't save the flooding world, so they saved the animals on it instead, with the intention of then when the land was habitable again, the animals went back. That's, maybe that's the original version of assisted migration right there. We can go right back to some biblical times. But in today's world, when we don't have a whole planet flooding, or if you want to think about it as a whole system flooding, you've got fragmented systems. It's an interesting question whether you put your energy into saving the individuals of the species, or do you put your energy into saving the altered environment so that that species continue to live there. And it really is a moral dilemma. It comes down to, what can you do? What do you think you have the right to do? And I think a big one that I think is really important that doesn't get talked about enough is, if you are going to do something about it, do you know enough, or can you do it in a way that will actually make a difference? I think that's such a, it's a classic example where we want to help, and we don't know how to, or we choose to help, but we actually end up making things worse. Humans, we are capable of such great change, and I feel like it can go in either direction. So for myself, I think, everyone can speak to their own morals. I think about it as, am I part of this ecosystem or am I not? And I fully believe that I'm a participating member of it. So that means that whether I choose to, save a spider, save a salmon fry, or whether I don't, I'm still participating. And so that will come to each individual and your own choices. But for the time together that we have today, I want to get everyone informed to the point that if you do choose to salvage salmon fry, that you've got a pretty good toolkit behind yourself, so that if you are going to do it, you can do it to the best of your ability, which I think is really kind of all we can hope for in today's day and age. So the first question we need to tackle is, what's the state of this emergency, right? Usually, depending on how your summer's going or what your drought conditions are, sometimes it's coming. There hasn't been rain for a long time. Sometimes you just get a really hot period, right? That was kind of like the heat dome. Or that was an extended heat dome, or extended time of heat, right? And so, is there a state of emergency? That's actually, it's not a statement, it's a question. And my response to that is that the first thing you need to do is don't panic, right? Let's take this from Hitchhiker's Guide to the Galaxy. I think that's the best of life advice that we could take from anybody. And so what I want to walk us through is, what are the parameters that are important for keeping salmon fry alive? How do we evaluate them? How do we assess them? And what can we do about it, right? So the first one, we usually don't use a lot of words in slides, but we'll try to do this to help our memory carry through, is dissolved oxygen. That's the most basic thing. Can you breathe, right? And so for fish, and specifically for salmon fry, what they need, salmon fry need around 6 parts per million of oxygen in their water. If it gets less than that, essentially you'll lose health and condition, and you start getting critical levels. And right, so that kind of gives you an example. If it gets down to 3 or 5 parts per million, they've really only got a day or so, and then their body's under too much stress, and they can't handle it. Now you might be asking, Kristina, how am I going to measure oxygen in a stream? Well, I will say, if you do have some time and some money, you could go get a handy fancy science gadget. There's lots of little handheld ones that you can get. Ones like this can be a bit more expensive. I think they're maybe a few $100s. But again, that's not really realistic for most people. Most people don't have a chemistry lab that they can go tap into to get answers about these things, right? So I'm going to give you a clue. Maybe you already thought of it. but you can get aquarium kits. People take care of the fish and their water so often, all the time. We have a whole industry that is built around this. I think this kit, when I was looking it up, was less than 20 bucks and you could get 50 tests, right? So if you were really worried about somewhere, just go get a couple aquarium kits. That's not too big of a huge burden. And if that's not accessible, that's also okay. Use your senses. Think about your environment. Look at the pond. Is there any flowing water still left remaining? If you put your hand in it, is it hot? Is it cold? Is there wind? You know, we don't often think about it, but wind is actually one of the main aerating forces of water bodies, even little ones, right? Creating a little bit of turbulence. Again, depends on the state of the pond. We'll talk about stirring up mud and things like that. But you can use your own senses, and usually you've got pretty good intuition, or maybe you just need to come and watch for a day or two, and maybe you can see that things are getting worse, you know. Use your best judgment. It doesn't require a bunch of fancy smancy gadgets to make good decisions up there. Okay, so big one, oxygen. Next one, temperature, right? We talked about this, you know, like humans getting heat stroke. Fish can get heat stroke, same thing, right? We sort of have these temperature ranges that we're all more comfortable at, but then there's also the temperature ranges that are outside of our capacity, right? Minus 40, you're not going outside without a jacket for very long. And so fish have the same ranges, or sorry, not the exact same, but they have the same tolerances, that same notion. So for salmon fry, this is again in general, you can get kind of persnickety about degree for degree, but in general, above 20 degrees Celsius or about 68 Fahrenheit, we're getting too hot for salmon fry. And then there's an inverse too. We don't often think about it, but again, if you start getting around that 5 degree mark or around that 40 Fahrenheit, you're getting too cold for them. So there's an optimal range for them, for their growth, for their survival. Another thing to think about, a little bit sciencey, but warmth and oxygen are tied together. So the warmer your water is, so the bigger your water molecules, the more it pushes air out. So what that means is that the warmer your water, actually the less oxygen you have too. So those two problems, that's why they are so intrinsically tied together. It's not just that their water body is smaller, it's that hotter water, harder to breathe. Hard time being a fish, right? At least when we get hot, we can still breathe. Another thing, which is so that's kind of just the actual temperature they're experiencing. And then it has to do with something called acclimation, or can they acclimatize? So this is kind of a cool graph. For any of my nerdy fish friends out there, the link to the paper is in the top right. But I'm going to walk through this, what this means, because I think this is really important. So that there's a difference between, how does an individual's bodies function, and then how does a whole population function when we have these temperature changes. So let's just look at the top one. So we're going to look at the one with the red line first. It's this idea that how well your body's doing is on the y-axis, and how hot it is on the x-axis, temperature. And so what it's showing you is that there's this kind of temperature range where I've got really good body function, and it starts getting hotter and hotter, and I'm not okay, and I'm not okay. And there's actually something that we call critical function temperature. That's what that CT stands for. So the idea being that you can get so hot that you stop working, that you die, right? And so that's that great. And so really, you can exist within a lot of those temperature ranges and be okay. Maybe it's not ideal, but you're all right. Right? And so we can take that, so think about the top graph, and now drop it down to the blue line, to the abundance graph. So the same rule applies to a whole population. You can have an ideal temperature and the most amount of fish will thrive, or that temperature can get a little too hot, and most of your fish are still hanging out, but eventually you're going to get to a point where only a few fish are capable of surviving, and then eventually, most unfortunate, to none at all, right? And that's what we're trying to avoid. Or we're trying to, hopefully sustain their habitat in a way that we don't get to the end of the line, as they say. So this is another, this is kind of a cool continuation of that. And so the same folks, so what they were looking at, this was also the study that I'm talking about. It wasn't specific to salmon. They went and looked at over 200 species all around the whole world. So it's kind of cool to see that it's a general rule that applies to everybody. Everyone's own set of temperature ranges will be less or more. So again, if we just look at the top one, and so they've got 3 colors, and each of those colors represents a region in the world, which is why I put the little color map on the side. So our polar fish are in blue, our mid-latitude fish are in yellow, and then our equatorial fish species are in red. And so heat tolerance is, what's that range of temperature that you can tolerate for, from your highest still surviving to your lowest not surviving. And then, how long does it take for you to adapt to that? And so you get this notion that like polar fish have the smallest range of temperatures because they can only get so warm. And then you can see that this kind of makes sense. Our equatorial fish, they're used to the most amount of heat. They can cover quite a bit of temperature change and they can be okay. But it has to do with how quickly that happens, right? So think about, if anyone here works in the kitchen or worked in the kitchen in the past, you're working in the hot kitchen, how nice it is to step into the walk-in freezer for a hot second, right? Well, it's a bit of a shock to the body, but it feels good. And we're okay with that. But if your whole system does that, that can be really bad. And so sometimes having a quick, flashy hot spell the last 2 or 3 days can set off fish. Even though it's not the extreme of their temperature range, it happens so quickly that their body wasn't ready for it. So it's a form of temperature shock is essentially what happens there. And so that's kind of actually something that I've been thinking about where I live, because 2023 was not as hot. That's, we go back to 2021 when we had our crazy heat dome. That's what's showing in the top left there. We didn't have, or at least to my knowledge, it wasn't recorded, a fish die off in the same way, even though it was way hotter for way longer. Versus in 2023, we had a massive, massive die off. Now, there's some other stuff that comes into context here. There's how much water was in the river each year. In 2023 versus, well, actually both years we were pretty low. But there's some other factors that come into play. But it's something to keep in mind in your own streams, in your own ecosystems. How, when you get those really hot spikes, think about your dog or yourself, right? You're like, whew, my body wasn't used to that. The same is true for your whole ecosystem. And especially juveniles are even more sensitive to that. So just something to keep in mind, right? We are constantly observing our environment. We're taking in that information about it. When you're taking it in, you can actually start using that to make some good choices and make some good decisions. Okay, next factor. If you are a stranded juvenile salmon, well, if you're stuck in a pond, you might eventually eat yourself out of house and home, right? So salmon fry actually require a fair amount of food, and they can live a long time without it, but they kind of go into a fasting state. But they can't, they will eventually die off if it's an extended period of time, right? So what are they looking for? They're looking for invertebrates in the bottom. They're looking for fallen insects from above, even bits of plankton, things like that. But I want to kind of take a bit of a walkthrough of their general life cycle, because I think that when we think of salmon, we think of the adults, right? That's what comes to mind. We think of them strong, swimming upstream, completing their life cycle, doing their spawning, and then going back out to the ocean. You think about those sport fishermen catching the big salmon, and I think a lot of there's a whole half of that life cycle that we don't really know a lot about, or I would say that most folks don't know as much about. So I think if we can understand that a little bit better, we can hopefully address some of those vulnerability issues. So we have the eggs, right? The adult salmon, they swim upstream back to their natal stream. The females, they dig a little spot in the gravel, have their eggs. The males come and fertilize them. And those eggs, as they begin to hatch, the first little ones, the little alien-looking creature in the center that I still think is adorable. So they are called, and hopefully I can get this right, alevins. One of those ones you only read in a book. You very rarely say it out loud, right? And so they have a pretty amazing little life. So those eggs are, they're buried in the gravel, and they have to make their way up. So sometimes it takes them a few hours. They usually wait until nighttime once they hatched before they try and swim to the top of the gravel. And one thing we don't often think about, because obviously fish are great swimmers, but when they're born, so fish have a swim bladder. You can actually kind of see it if you look in the bottom right photo, that kind of clear translucent line going through the center of the fry there. So that swim bladder is how they control their buoyancy. When a salmon hatches, they don't have any air in their body yet. So that little tiny alevin actually gulps air, and it takes the dissolved air bubbles out of the water and starts to fill its swim bladder for the very first time. So that's when we say we get to a free swimming fry, is when it's finally stabilized its air bladder, that it gets neutral buoyancy. And then for the rest of its life, it will then control its buoyancy with dissolved oxygen. And the air that it's gulping isn't for breathing. It's literally like forcing, like if you and I were to just go and swallow air, but we send it to our stomach. We didn't send it to our swim bladder. But that's what they're forcing extra oxygen into their body, which I think is so cool. You didn't even think about that, or it hadn't even occurred to me before that they would need to get their own oxygen supply when they're born. Now, once they're born, they hang on to that little yolk sac. So if you look at the bottom right, kind of that bulgy belly, not because it had a lot to eat. It's because for the first this is very species dependent, but for the first window of time in its life, it's not really feeding yet. It's actually just surviving off of the nutrients from its yolk sac, and then it will start to feed and become more successful. And again, species dependent, this is on the scale of hours to weeks, or depending on your environment that we're in. Now, another thing that I think we often forget to think about, and again, depends on water body, but that salmon fry are not strong enough to swim upstream. So that means from wherever they're born, that's kind of the maximum limit. And then what they do is after they make their way up out of the gravel on their little fry, they get swept downstream, arguably maybe a bit aggressively, depending on the stream that they're born in, until they can settle out into a pool. And then they try to hold their ground. And again, depending on their life cycle, this can be on the scale of weeks to up to a year, couple years. Then they're trying to hold their ground in that section of the stream next to all these other salmon fry. And they're actually really territorial. The next time you have time, sit and watch them, because they have these little areas. And so, I should have gotten a different picture of this. So the way that pools work in streams is that you're kind of going along, and then there'll be a riffle, and then it kind of drops. And that's the shape of the stream bed I'm talking about. And so what that means is that right at the crest of the riffle is kind of like the best place to be, because all your food is going to be swimming past you or floating past you, bits of detritus, whatever they can catch. And so the more aggressive or larger fry get to the front of the line, and they catch the best food on the way by. And then the smaller, runtier ones are competing, so they actually get pushed further back. So there's a whole little social hierarchy that's happening in there. And they do their best to hold their ground until it's time for them to make their journey out to the sea. So what is it that they're trying to catch as it's floating and whirling by? Well, if you don't like creepy crawlies, the slides might not be as cool, but they are pretty awesome. So there are stonefly larvae, right? These are the nymph larva stages of a lot of our aerial insects, right? They're born in the water, lots of great nutrients there, and then they come out and shed their little exoskeleton and go off and grow wings. The little tiny larvae on that fingerprint there, those are actually black fly larvae, right? So there's another, all those little nice biters for you. They're coming from your water bodies too. Now, if you didn't think those were cute, I can forgive you, but these, I hope you still think are cool. So these are caddisflies, and they are my favorite things to find when I'm in the stream. Admittedly, little centipede dude without his house looks less cute, but when you see them in their houses and they're like little hermit crabs and they're trying to wiggle around and hold on to the rocks, it's pretty, I can sit and watch them for hours if you'll let me. But these are caddisflies. They build their own houses out of whatever material is available, small pebbles, spruce needles, bits of wood, right? You can kind of see all the different ones. And I didn't realize this beforehand, but they actually build it out of their own silk, right? So it's an underwater silk that they form, and they build their house as they grow. So the house it starts at the end, and as they get bigger, so it tends to be cone shaped as well. They can take on all sorts of different shapes. They can even be a bit spirally, sort of whatever they've got to match their environment. And it's one of those ones where you're like, Kristina, I've never seen one of these things. So admittedly, there's a time when they're going to hatch and then they'll be born. And so that hatching is also a big yummy time, but they're, the fry are coming after them. But it's one of those ones where once you see them, you can't unsee their little houses. So this was me at work, again, about 2 weeks ago, because I was gone for a conference. And you can just see, and they're all just clinging onto the rock, because them, just like the salmon fry, are trying to catch bits of plankton and little, even zooplankton that are going by. And so they're catching things along the way by. So they're also in that high flow zone. That high flow zone is also where there's a lot of oxygen. So even if you've got kind of a slow, sluggish river, those ripples are what help aerate it. So it's a highly productive place. So that's kind of one end, right? This is what the fry need to eat. But as we all know, if you are eating someone, there is a good chance that someone else is trying to eat you. So that brings us to predation. And I think this is the one that really gets our heartstrings sometimes. This notion that all of these fry have nowhere to go and they're essentially just a drive-through. They're a buffet for some other predators hanging out there. And that could be different bird species. It could be other fish species, right? And really, in a stranded pond, heron just needs to see it, and it could fly in and clean out the whole batch of fry in an afternoon or a day, right? See, I think our sense of justice, it seems unfair for all the little fry to get trapped there. And so those are kind of the big four that we're contending with, and those are the things that you need to think about when you come to a pool of salmon that seem to be stranded. And it could also be trout too, but we'll stick to the salmon narrative for now. So before you think, oh my gosh, I need to do something about this, you need to ask yourself a few questions. Do they have oxygen? Can they stay cool? Some streams, it might look like a really small pond, but when you put your hand in it, shout out to my groundwater friends out there, because that's what I study. I'm being a little silly. That can actually be kept cool, and that groundwater can actually even bring in oxygenated water, depending on the system and the sand and gravel, right? So do they have oxygen? Can they stay cool? Do they have access to food? And that's a longer term one, right? Some of these droughts, they might only be in a pinch for a few days. Other folks, we're talking about weeks. So that food thing becomes more and more important as time goes by. And are they safe from predation? Those are your big four questions you need to ask yourself. And if the answer is a big no to any one of these, then you come to the rescue. Well, actually, it's not as exciting as being Pam or David, because real rescuing is usually less glamorous than anything that they've ever done roaming out on the beach there. The first question, we've kind of established that they're in a condition that, is deteriorating. The first question you actually need to ask yourself is, do I even need to catch them? We want to help so badly. It's kind of a classic first aid thing even, right? In situational training. What's the thing I actually need to do here? And for anyone else who was a little kid who loved building, little rivers and streams between ponds, seriously enough, that can often be enough. If you have a series of pools that are disconnected, if you think that you can reconnect them, the fry themselves, you might not see them move right away, but if you can give them options, they'll often do transitions at night, right? Again, that predation factor comes into play. And so don't be afraid to get your niece and your nephew, your shovel and bucket, and just connect up some pools. If you've got the type of stream bed that can allow for that. A lot of us have cobble beds, so that's not even an option, even if we wanted to. But if this is something you're working with, that is a completely viable option. The other thing you need to think about is, if predation is your main concern, you might not have to change the pool. Maybe you can just help cover it a little bit with what's already there. So it can make a huge difference if you think about that heron coming and snooping. If you can lay some big branches over top, you don't want it to go into the water. You need it to kind of somewhat be above, because you want to give them the most amount of options, right? But just even being a little bit shaded, a little bit covered, might make a world of a difference to those salmon fry. And ideally, like live branch is good. If you can kind of weigh down one end of it, or stuck it under a rock on one side so it shadows over and above. All of those aerial predators, right? You're losing that initial snack time moment, which can make a big difference. Okay, but let's say we get to the point where you can't do anything about the pool structure itself, or you can't add any coverage to it. So then you do need to ask the question, well, how am I going to catch these fish? Again, this depends on the size and scale of pool that we're talking about here. Sometimes you can get big sign nets and you can kind of like drag those across and then net them on the side. For what we're going to talk about today, I'm just going to talk a bit more small scale, but if you want to level up, I encourage it. But what I'm going to talk about is kind of what you could just do as one, maybe even two people, right? Kind of the difference that you could make there, right? So just think your classic dip net for me, a kid, that can do it. You can also use something called a pole sign, which is kind of cool. So there's really big ones, but this is a mini version where you can kind of hold both sides and then you can scoop that way. And The one thing I do want to bring up though before, and we're going to talk about the traps because the traps are kind of cool. And I'll talk about those in a bit more detail because I think that's more foreign than what most people would be used to. But the big thing, if you are going to catch any fish, you're going to catch any salmon fry, please remember that they are already in a sorry state. If they are under high temperature, low oxygen, and no food, it doesn't take that much stress for them to go over and above their limits, right? So you don't want to chase them around. You don't want to muddy the water. You kind of got to try and do it sort of slow and methodically if you can, if you are going to do the netting. And that's why I kind of, whatever's accessible. That's kind of one of the reasons why the traps are nice, because you're not disrupting what limited environment they have left. You're just putting something in for them to then enter, and then you can catch them that way. So let's talk about, these are called gi traps. And again, if you're curious, sort of money-wise, I mean, obviously dip net you could get from maybe your dollar store pole signs, maybe like $42. You can order gi traps online for maybe $20. So none of this is a huge investment, but hopefully accessible to folks. And so this kind of gives you an idea of how to set it up. So the trap relies on bait. And this I find so funny. This is from and I'll share some of these resources at the end, folks. But this is from a module of how to run this. And admittedly, they were doing it for sampling. They weren't doing it for salvage rescue. But they said use a bit of salmon roe is the best bait. But there's a certain amount of irony when you're trying to save the salmon and you're using salmon eggs. I think it's funny. But what they also say you can use is a bit of sort of fish flavored cat food or some wet cat food that you open the tin on. You take like a nylon or something to hang it by on the inside. But you need the bait on the inside, and then you close the trap around it, and then the fish will swim into either side and come and peck at it. You ideally, if you can leave it there overnight, but sometimes even a few hours is enough, depending on your time and, the proximity to your home. Maybe it makes sense you can, leave it on your drive home from work one day and pick it up on your drive home from work the next day, right? You got some options there. And so just keep in mind, you want your mesh between about 1/8 of an inch and 1/4 of an inch, regardless of which one you're using. Now, the actual salmon that we're trying to catch, right? So when we're thinking about this, depending on the species, their time in that stream is anywhere from a few days up to 3 years. And so that window of time to be helpful can vary a lot. And it also should be part of your decision as to whether or not it is appropriate to even move them, right? Maybe they're on their way through or whichever. And you can also be too late, right? That's the other thing. So you gotta, wherever you're from, try and learn about the salmon that are in your area so you can understand when you should be looking, right? For spring spawning salmon, this is not really a big hot topic, but our summer spawning salmon, that's a bit more of a big deal, right? For those eggs that are being hatched in that August, September period. And so just kind of something to keep in mind, right? So our chum and our pink salmon, they migrate to the ocean almost immediately after they emerge from the gravel. Sockeye, they can migrate to lakes. And then our coho, our chinook, and our steelhead, or some of our steel run trout, they're the ones that spend more than a year in the stream. So I would maybe say those might be some of our more vulnerable populations. Oh, actually, and I always like to do this because I think I finally remembered it before we move on. But if you don't already know it, this is a great way to remember all of your Pacific salmon, at least on our side of the ocean. So I usually start with the pink salmon is your pinky, chum rhymes with thumb, sock eye, and then I always got to mix this one up. Coho and chinook. Which one's bigger? The chinook is the king salmon, and then the coho is the next one down. It's like the largest one is your king salmon. See, even I still haven't got it locked down. But that's a great way to remember all of your salmon species. So do it by the palm of your hand. Now, this is kind of a fancier gadget, which is 100% not necessary, but I just wanted to show it to folks because I think it's something that most fish bios have in their pocket. And I think I might get my one for myself this summer. I've always been kind of jealous of them. And I think you could definitely rig one up. So don't feel like this is a necessity by any means. But they tend to call them photariums. They're becoming also common with bigger ones for people who are doing, even fishers. They can take a picture of their fish in the water and release it. So they're becoming a bit more common. And I think the money from them does go to the Wild Fish Conservancy. So that's a good thing too. But essentially it's just having a little clear box so that you can slow your fish are in a small enough container you can actually see them to identify who they are. This also part is again a bit next level. Fish are also very fast, And these are little tiny features that you're trying to find. So you can actually, there is stuff you can use to quote unquote slow them down. An accessible one is Alka-Seltzers. I'm saying this only if you really want to go way far. I would say for 90% of people, even just having a chance to look at them is pretty great. So if we want to figure out which salmon we're actually looking at, we need to get used to some features, right? We need to start thinking about what we're looking for. Right, so we're thinking about their jaw, their maxillary bone, their different fins, and those sizes of fins is going to be important for how we can tell which species apart. And then what I like to call spots or stripes, which really are par marks. So again, little salmon fry are trying their best to stay alive. They're relying on camouflage from above, below, from the sides, right? And so they have lots of different marks, or lots of species have them. And those marks are one of the biggest ways that we can tell species apart. So this is the book that I have. I've actually got it with me here today. I'm sure there's lots of other great resources, but I just thought I would show you all one. So this is by Pollard, Hartman, Groot, and Edgell. It's only, I don't even think it's 20 pages. Maybe it's 10 pages. But it's got really great visuals for how you can start to, tell which little fry you're looking at. And this does have trout and salmon. I'm going to keep talking about salmon for now, but this all applies to trout as well for today. And so just right off the bat, there's some really simple things that we can look at to identify, are we looking at a trout? Are we looking at salmon, right? We're going to get into different life stages. Are they androgynous? Do they go back to the ocean? Do they not? And the simplest one is the length between, or you could say the width maybe is a better way to think about it. So how wide is their pectoral fin, their dorsal fin, so the fin at the top, versus their anal fin, so the fin sort of at the bottom and at the back, right? So if the top is narrower than the bottom, then you've got a salmon. And then if the top is wider than the bottom, you've got a trout or a char, which is actually, saying it in here is pretty simple. Watching a tiny, fast swimming fish can be harder to determine that. But in general, that's your first clue. Am I looking at a salmon? I'm looking at a trout. Now, the next part, so now we've got it down. Okay, we're looking at a salmon. Great. Now, remember, we need to go back to our hand. We've got 5 potential fingers or 5 fish that it could be. The easiest one to figure out is the pink salmon. The reason being, it's the only one of our Pacific salmon fry that doesn't have any spots, right? So if you, and again, remember they also spend some of the shortest amount of time before they head to the ocean. So these are ones maybe you might be least likely to see, but are the easiest to identify because they don't have any par marks at all. Now, once we get into our other 4, when we start looking at the par marks, again, this is why there's lots of details and there's lots of ways you can identify them. You can even get microscopes out and get down to a certain level. But the easiest way I think to think about it is, do we have spots or do we have stripes? And that might seem a bit silly, but it has to do, think about, so the way that they use as a reference mark is the shape or the diameter of the fry's eye. And so if you look at their eye and the spots are the same or narrower than the diameter of the eye, of the width of the eye, then you have either a chum or a sockeye. If you look at the eye and the par marks are longer than it, I'm going to call those stripes, then you either have a coho or a chinook. So already we're actually doing pretty good. If you think about what we've learned in the last minute, we've gone maybe from not being able to know any salmon fry to being able to narrow it down to pretty much 3 big groups. Now, trying to tell the difference as we get more and more finer can get a little bit trickier as we go. Telling the difference between a chum and a sockeye, if you're looking at your little salmon fry. So for our chum, you can kind of think about like organized spots versus disorganized spots. So the chum tend to all be above the lateral line, so that's kind of the midsection there, and they're fairly even, whereas our sockeye, they're just more chaotic. They got spots sort of, they're more leopardy, they're all over the place. So if you want, right, so that's for our chum and for our sockeye. Another thing is that the color of their belly, if that's maybe not super helpful, the chum tends to have a bit of a greenish belly versus a sockeye has very definitive white or silver belly. So again, you kind of have to start seeing them to make comparisons like that, but those are just some very basic clues to get you on your way. Now, if we get to our striped friends, again, it's kind of, we're getting into harder and harder details. A couple big ones, if we look at our coho friend here. So if you look at, again, if you look at that anal fin at the bottom, a nice giveaway is that our coho has a black stripe on its anal fin that the Chinook doesn't have. It also has what we call a sickle shape, kind of like that concave fin, right? So again, this is pretty easy when we're looking at a nice still drawing and our fish is not swimming at super speeds, right? But that's why having little tiny containers and little clear ones, this is much easier. Notice all these ID features are from a side profile. Looking down on them is much, much harder. But I also want to point out that you don't need to ID them to salvage them, right? It's just if you're curious. It's just if you want to understand a bit more of what you're helping here. You can still do this certainly without all those steps. So let's jump back into what do we need to do a successful salmon fry salvage. The short answer, once we have our nets and our friends, is buckets, 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 and more buckets, right? You want to fill them with water before you capture the fry. That's so important. It's one of those things where think ahead, right? You want it to be clean. Again, if you're capturing them from a small pond, you probably maybe shouldn't, or there isn't enough water for you to be taking it from there. So ideally, if you can, you want water that's not going to shock them either. So you can't just fill your tap water up and bring that down. If it's possible to go to the place where you're going to put them, get that water, or at the very least, and a little bit cooler. That's another thing with temperature shock, is that it's easier to go to slightly cooler water than it is to go to slightly warmer water. Again, don't put too many fish in per bucket. Oxygen is a thing. All those little fishes, all our fry, they need to breathe. And so you don't want to overload one bucket. It's better to have sort of several half full buckets than it is to carry around a couple big ones. And that's also true for you carrying it, right? The last thing you want to do is go through all this effort to save them, and then carrying a big heavy bucket, you trip and stumble and they all go whoosh. I don't think they're going to have a very, very, very good recovery out of that. It might not seem, even if you're only going for about 15 minutes, it actually really is important to aerate them. See, again, think about the number of fish that you have. These little these are battery-powered portable air pumps. Again, think about aquariums, right? The stuff is not as inaccessible as you might think. They're about, again, in that kind of $20 range, and you can turn them on, put them in their pump, and then your fry will be good for how long it will take you to transport them. If you're doing bigger transports or longer times, I highly suggest reaching out to the DFO if you're in Canada, Fisheries Department, asking for resources. Italian. Small scale, there are things there that you can get some help with. Now, this is something I want to talk about. There are rules and regulations about transporting salmon fry, and we're going to talk about those in a second. But I want to explain the biological reason why this is so important. So this is a very big diagram of sort of a salmon's life cycle, and I want to bring our attention to imprinting. So salmon, they go back to their home range, to their home streams. They can actually get confused and go other places, but 90 whatever percent of them amazingly make it back to the same sections they were born in, sometimes 6-7 years later, which is crazy. And what people most maybe don't know is that they're doing that by smell. So our streams, just like you and I, right, they have a specific smell that is based off of the rocks and the vegetation and the chemical processes. And salmon track that smell. So if you move them out of their home range, they will never get back there. That's that imprinting time. That's what happens when they're fry in their stream. For some of them, it's a shorter time, but it's such a crucial, crucial part of their life cycle. We don't want to disrupt that. So if you are going to be moving them, you need to be really conscientious about where you're putting them. And that's from a sort of a big life cycle point. And we're going to go through a few more practical ones. So let's say, and again, these are all things you should have thought of before you have a salmon fry sitting in a bucket. This is all, I'm going to make a joke, but it should all be premeditated. So let's say you have, now that you've caught your fish, what are you going to do with them? Well, you need to, before you have any intention of moving them, you need to find a better place to put them. It isn't helpful to move them from one desiccating stream bed to another. It's not getting anyone ahead by any miles. You also need to think about predation, right? Are you putting them somewhere that they're going to be even more vulnerable to? So again, we're not fish, but think about they need sort of cool, deep places. They need, again, some shelter, some cover from above, right? Leaving them out in the open isn't super great. A big one, which I think is hard for most of us to comprehend, and I'm not going to say that I have a perfect answer for this because I'm not a fish biologist by training, is overcrowding. So if you think about it, this ecosystem is already in general under stress. All these bodies of water can be already at capacity. So moving fish from one area to another is just creating more competition, right? So this is why it kind of comes down to that moral dilemma again, or not moral, there's some science behind this one, but you have to be really conscious that you might be making these fish lives better, but potentially making other ones worse. And so think about the streams that they're in. Think about the connectivity. If you put them in somewhere, can they drift further down and find a better space, right? So it's just really important to think about. And this is what I want to talk about needing approval. If you are joining us from the US today, please double check your own rules. I believe they're the same as ours, but I couldn't find the right paperwork on it. So on a small scale, you do not need permits to move fish, move fry, if one, you stay in the same system. So from any location along the stream, if you move the fry downstream, you do not require a permit. If you go to move the fry upstream of where they are and there are barriers, you may require a permit. So again, if you're just starting off, unless you're going to become a savant of fry salvage, focus on moving downstream. It also is more logical because you're going to larger bodies of water, which means that you're likely going to have hopefully more stable flow. So it also makes sense from a perspective of that. And then you 100%, and I don't suggest anyone doing this without a fish bio and some DFO approval, if you go to move them into a different tributary, that requires a permit. So just keep that in mind. Again, we want to do our best and have our best do the most work. And the last part of this, which might not be everyone else's most exciting part, but is record what you do. And the reason why this is so important, and I think on multiple levels, one, if this is a chronic appearance and you need someone to acknowledge that, hey, your stream is in trouble. Hey, like change, we need to start changing how we're stewarding our ecosystem because this keeps happening. Then you can show them, look, I've done this 2 years in a row. I've done this 3 years in a row. It's the same spot. It's this, it's that. I wish that we could just come to someone and say, hey, this thing is happening, but we tend to have to provide evidence, right? And so track what you do. It only takes a few sentences in a journal or, the notes section of your phone if you date it to make a really, really big difference long term. So hopefully we're getting near the end here. I'm just about done. Hopefully that's giving you some fun ideas or some inspiring ideas for what it is that you can do for your salmon population because they're so intrinsically tied to our whole ecosystem. I just want to be maybe a bit sobering on this. Acknowledge the reality of it. And you can kind of think about this in two different ways, but this is what NOAA has. It's called the salmon survival pyramid. For every 3,000 eggs that are born, only 300 make it to elevation stage. Only 50 of those become smolt, or does it fry, or pre-stage, post-stage to fry. 4 are going to be ocean adults, and only 2, again, this is species slightly specific, but only 2 of those, out of those 3,000 eggs, are going to come back as adults. Those are some rough odds, right? And so on one hand, you could make the choice of like, well, Kristina, not a lot of them survive anyway, so why? But that also means that for every single one that we can up those odds, we are getting closer to that survival of those 2 spawning adults who will also come back and then lay thousands of eggs upon themselves or for themselves. And so depending on which side of the fence you sit on this, I always like to bring up someone, I had a very similar dilemma in a management situation 10 years ago, and someone helped me through it because they told me the sea star story, which is why I wanted to share. I think I've got time. The short version is that there was let's say there's a really high tide, and for some reason all these sea stars got washed up way higher up the beach than they were supposed to be. And these two friends, and there's thousands of them. There's more than anybody can pick up, and the birds are coming and they're eating them and pecking them, or they're all starting to perish. And there's two friends walking down the beach, and one friend doesn't pick up any of the sea stars, and the other friend periodically just grabs one and throws it in, and grabs one and throws it in as they're going along. And the first friend was like, why are you bothering? You can't save them all. And the friend says, well, maybe I didn't make a difference for the whole population, but I made a big difference for that one sea star. So hopefully, everyone can make a difference for that one salmon fry. And lastly, I know I'm getting close to the end, but this is already happening. This is happening in communities all over the place. These are examples from here in British Columbia. This was a partnership. And I just want to show, this is a quick excerpt from the article of how, there's one, Murray Scott, he arranged access to the creek for his neighbors, and he brought them a tool when they need it. Like, it's these small things and connecting in your community that can make a big difference. And it is happening also on a big scale. This is the Pacific Salmon Foundation. This was May of this year, right? So they've put 1.4 million into different salmon projects, funding over 100 different communities to try and support salmon to the best of our ability. And it really can happen on a community level. This is from the Kitsamakalam Band. This was tied into Nature Kids BC, tying into school programs, things like that. So there's lots of avenues, lots of potential. And yeah, normally ends with just a pretty photo, but if anyone was curious, a lot of that information that I shared with you today is from the Pacific Stream Keepers Federation, which is tied to our Canadian DFO. So please go look them up if you want to learn some cool things. And I will close with that. Oof, just under the wire. Pass back to you, Rob.
All right, thank you, Kristina. Now, before we start in with the question and answer session, I would like to remind everyone, if you do have some questions, feel free to submit them via the question field in your control panel. So let's talk about bears for a second. How is this affecting the bear population, and how are we, and their behavior as well?
Yeah, that is a great question, right? So for most of our coastal bear population, salmon is super key element in their diet. And so again, we're just having dwindling populations. They're not returning to the same stream. So if you think about, just as an example, those 84,000 fish that didn't come back, there's your adults that are not carrying back. So what you're essentially seeing is a breakdown in your food chain or your food web. And so that means that either you have a decline in bears, or you have those bears searching for alternate food sources, right? So if they're in a catchment, they're in a stream area that they used to get salmon from, but now they're not, and that's a national park. That's, again, you can see that crossover of, going into having more negative interactions with humans because their primary food source is missing, right? So again, focused on the little salmon more than the bears, but it's all connected. It all comes back together.
Great, thank you. So you showed us a photo of human overcrowding. Could you tell us where that photo was from?
I think that was from India. I apologize. I pulled that one off of our Google Web. I do a fairly good job of quoting, but I just typed in overcrowding on Google. You caught me there. But yeah, very busy markets.
All right, no worries. Well, that looks like to be the last question that we do have for today. So I'd like to throw it back to you for any closing comments you may have.
Thanks, Rob, and thank you everyone for joining in today. I think in today's climate crisis, we often are left feeling like there's not a lot we can do about it, or how do we respond, right, to this sort of big, overwhelming force that's around us all the time. And whether or not you live close to the coast and maybe have salmon fry in your backyard, I hope that everyone can find these are ways that we can actually take action. And there are lots of there are lots of the classic ways too, but every little thing goes a long way. So that's what I hope to close on today. Thanks, everyone.
Kristina, thank you so much for taking the time to present for us today. And I'd also like to thank everyone who tuned in today. If you are interested in information on how you can travel with NatHab, please give us a call at the number on your screen, or you can send us an email at info@nathab.com. Our adventure specialists are happy to help you out. Join us Friday For our next Daily Dose of Nature, you can check out this week's lineup, including our registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I will conclude today's webinar. Goodbye, everybody. We'll see you next time.